Should we start, you think? Okay. Good evening. Hi. The snow has gone away. Yay. No more snow for a while. So we're going to kick this off. I know some of you have been in this room before where we've talked about this, but tonight is actually the night. So we're going to do a bunch of stuff, but I wanted to make sure we reset what it is we're trying to really achieve, okay? The goal that we're really trying to do with this community is to bring people, process, technology together in order to do stuff. It's not just a case of talking about it, listening. We really want this to be an active community where you get an opportunity to build things, okay? To that point, I'm gonna point to some bags. Those are prizes, okay? So what we're gonna try and do is a little bit of incentivizing you guys. So tonight, a number of people will be given, or at least going home with a bag based on the fact that you asked amazing questions. So if we have any amazing questions now, you could be the first person to get a bag. No? No amazing questions yet? Okay, give it time. But I just want to make sure that you kind of remember that. So again, make sure you interact with this. Your job is to take as much information out of this as possible. It is your community. It is driven by you and your needs. Okay? So please make sure we understand what it is you need. We're going to come together to solve problems. Again, I'm going to hark back to the fact that I don't want you to just to sit there and kind of go, great, I heard some stuff. We actually want you to be actively involved in building things, trying this out, okay? So what are we going to do? Well, today, we're going to get started. We're actually going to go, Carlos is going to take you through some getting started with Azure. I'm going to say basics, but it's a little bit beyond basics, but it's good stuff. We're then going to take you through a series of weeks, but you're going to see a couple of things which are going to stand out, like one of which is called a hothouse. We could call it a hackathon. You've probably heard of those. But the idea is you are going to get into teams. Maybe it's teams you're already in. I believe there is a team that's already formed in the room, yes? Some of my colleagues from Emerging already have a team. We already had, who knew that we'd bring a team? But the idea is, again, to take some ideas and build them out, okay? So as the weeks progress, you should be able to build upon your ideas. And if you're really struggling for ideas, we have a number of people in this room who can help you generate some ideas to get you started, because we believe that actually putting this into practice is when you really know that you know this stuff, okay? So we'll take you all the way through till the middle of January, where you can see we're gonna have a nice break over Christmas, but it isn't really a break for some, because it turns out that if your mind is already active and wanting to do things, that's a really good idea and good time to play with these things. So we're gonna have a demo pretty much towards the end of January. You're looking at those, a couple of weird dates around there. If you reverse the 16th and the 23rd, those dates will make much more sense. So on the 23rd of January, we're going to finish off, okay? We're going to basically have a final event where anything you build will get judged, okay? We have a nice judging criteria. We have a nice team that's going to come and actually help you, or at least decide for you, who wins the beauty competition of who built the coolest app, idea, service, you name it. What we're looking for is your cool ideas demonstrated in this room. So that's it. That's really as simple as it gets. Just to kind of pull back that hothouse idea, though, it really is just about giving you an opportunity to try out a bunch of things. Okay, so consider this as the room in which the ideas get planted. Your job then is to take that idea away with your colleagues and build upon it, okay? So we're going to share this out because it turns out I put way too many English words on this, way too many. I'm looking at it now regretting this because I kind of want to read it, but I'm not going to. I won't put you through that pain. But it is about solving real problems. Think about a problem that you believe Azure could help somebody with, whether it's yourself, whether it's the organization you work for, whether it's the customers that your organizations serve. It's all about solving real problems, Okay, so we're going to judge it based on those real problems. Normally, this is a very intense 3 days. Turns out it's really hard to get you guys in a room for just 3 days. So we're going to give you multiple weeks. Okay, so it'll be a little bit less intense, but it is about getting feedback from people. So we're going to be accessible to you. In other words, if you need feedback from someone, is this a good idea? Am I going in the right direction? There are a number of people in this room that can help give you that feedback. We're your pseudo customers, for want of a better term. What else do I want to tell you? It really is focusing in on a single challenge, okay? Now, the challenge isn't going to be one set by us. It is going to be the challenge that your imagination opens up. However, you will be competing against others, okay? It is a beauty competition. Who builds the coolest stuff? Or even who has the best idea? We're going to give you feedback or opportunities for feedback at every session. So next week's session, for instance, has a hothouse element in it. Basically, that means we're going to help you form teams, okay? If you already have an idea, there will be people stood at the back of the room. One of them will be me, who you can validate those ideas against, okay? So while you're learning, there is going to be people who can actually give you great feedback. You can also steal, beg, and borrow ideas from everyone else in this room. If somebody comes up with a good idea and you think, that's a great idea, that's mine, it's okay. There's no, it's fine. That's all good. It's Christmas. See it as a gift from someone else. You could, if you really get so far, take this idea to market. You could take it back to your company. You could take it back to your boss and say, this is the cool stuff I did with this time. There's no real structure to the hothouse sessions. Why? Because it's more around letting you guys play with their ideas. Yes, there's structure to the learning elements. There has to be, okay? They follow a very strict path. But your ideas are going to appear in your head, well, as they appear. The job is do you have a team? Do you have people that you can get feedback? Do you have the knowledge then to put that into practice? Well, we're going to bring the experts into the room to make sure you have that guidance. And again, just in case you didn't realize, oh, hi, Igers. Where is he? Igers. Participants, please don't shy away from borrowing. You're at the back. I see you now. Go away. That's it. Thank you. Don't shy away from talking to each other. There's going to be people in this room that may not be stood at the front who will have the idea that you need, that will have that piece of knowledge that if you just tap into, then you can build something incredible, will help your idea. So please do look at every other person in this room as a potential source of knowledge, okay? There is other help. Well, you know some of this. Some of this is a very quick promo of the other communities that are happening. If you're not already an active participant in these communities, I would highly encourage joining said communities. There are people here. You probably know most of these people. Aldis, do we all know Aldis? There's lots of yeses. Yes, we all know Aldis. Okay, good. Otherwise, you can go onto the web. You can come talk to us. You can go on valueflowquality.com. There is so much information that you can get that we can help you with. All you got to do is ask. And that's it. Have fun with this. Do ask amazing questions, because no one's asked a question so far. Yes.
Amazing good question. How much people in D?
5. I nearly went 4, but I meant 5. So ideally, we'd like a team of 5 people. Why? 2 people is an argument. 3 people is 2 people ganging up on 1 person. You know how this works. It's human nature. So ideally, we would like teams of 5. Okay? If you don't want to build a team, good, don't. But we're going to encourage it because, you know, teams are going to win prizes. But also, I think genuinely, it really helps to put these ideas into practice. And the only way you're going to do that is you either fly solo and work really, really hard, or have some people to pair with, okay? So I think that's possibly the first good question. So would you like to? Yes, please. I need an assistant somehow. Thank you.
What's the greatest idea you have heard in previous hackathon?
Oh, nice. Okay, craziest idea I've ever heard in one of these sessions is hydroponics, where, well, okay, I'm amongst friends, yes, and on the web. And if you look on our website, you'll see some of the companies that we work with. There's some very large companies in the world, maybe one of the largest companies in the world. That's a big shopping supermarket type place. One of their ideas was to put hydroponics on top of the roofs of the supermarkets to grow fresh vegetables, until they realized how many people they served fresh vegetables a day, and they realized they need a bigger store. So that was possibly the craziest, best, most inventive, but yeah, that was pretty good. So these kind of things, and we've moved away a little bit from hackathons because I think every company does hackathons. I mean, I know it's a renaming. If I take hothouse to Sweden, it turns out that's a sauna. So that doesn't work either. Greenhouse, again, we're growing vegetables. The idea is, again, it's a place where we can grow and shape ideas, okay? I think I'm done. Any more questions? That was another good question. We'll remember that one. We good? You happy? Thank you for attending, by the way. It's good to see you all. If you have friends, bring them. There's empty seats. Fill up the empty seats. That's it. That's enough from me. I'll be sat somewhere at the back, hiding or drinking water, something. Otherwise, I'm going to pass you over to Igers. And I will stop sharing and you can share.
All right.
Carlos, not Igers. I had Igers. Why did Igers? Why are you in my head? It's because you sent me messages. Sorry, Carlos.
No worries. I can be Ivers if you want me to be, or whoever. Oh, sorry. So, right. First of all, really big thanks for all of you coming out for this event. I didn't actually expect that so many people will show up. I'm glad to be surprised. So, as Stephen mentioned, we're gonna talk really on basic high-level terms about Azure as such, and I will kind of glance over a lot of topics. But the idea here is that any of the topics you see that pique your interest and you would like to kind of go deeper down the rabbit hole on that one, we'll have a separate session where we'll do exactly that. We'll still figure out how to collect the feedback about the topics of interest and how to decide to do those and in what format and where and how. All that's gonna come in due time, if, of course, there's an interest from you guys. Clickety click. Not clicking.
No.
Oh. Clickety click. Oh, now it works suddenly. So, shortly about me. I've been in IT for quite a bit, working with Azure for, well, a bit more than 4 years now as a solutions architect, which means I don't really code that much as I think about, problems and solutions for them. I've been certifying quite a bit. Quite recently got the Azure Developer Certificate, strangely enough. So someone somewhere decided that I would be a good candidate to do this talk. I work for a company called Visma, which is one of the biggest software houses in Europe. We have quite a big presence across Europe, quite a few employees, and most of the portfolio is all based on cloud, different platforms. The company I work for in that group is Visma Labs. It's a staffing house, basically. Visma has quite a big application portfolio, and these are developed by different teams, and some of the parts of these teams reside in Latvia, so we currently have about 220 colleagues and work quite a few technologies and cloud providers as well. Yeah, so today I'm going to have an introduction to Azure, talk about benefits of hosting applications in cloud, container options in Azure. We're going to take a bit of a closer look at the Azure App Services, serverless components, and Microsoft Cognitive Services. All right. So let's take a brief look in the history, how we came about, to actually talking about doing applications in cloud. So In the 90s, it was a typical that developer did all their work on their physical machine, not too cool on the both setting up the machine and also using the resources and kind of transferring the knowledge, and the setups might take quite a lot of time, so not too efficient on the resource side. So in 2000s, there was a switch over to virtual machines, a lot more efficient, easier to provision and work with. You know, you had your templated setup, you used that, and you could get your work quicker. In 2010s, we started to talk about cloud infrastructure and hosting both application and development environments on cloud, and typically talked about, you know, virtual machines, but in Azure, not on your, or in cloud rather than on your own PC. And from 2016 onward, we start hearing, you know, born in cloud applications that are developed using smart components in cloud, you know, kind of shying away from the virtual machine stuff and trying to do something smarter and cooler in that way. Yeah, so cloud service models. It's important to understand that depending on the model, also what you have to manage and what the service provider manages differs. So in the traditional infrastructure, everything ground up, starting from power, cooling, networking, storage, and all the things that go up the stack, operating system, middleware, runtime, data, applications, all that was your responsibility, or someone who did operate the applications or the environments. With infrastructure as a service, you kind of move away the responsibility for handling, you know, everything up to, well, parts of operating system to the service provider, but you still have a responsibility of middleware, runtimes, data, and applications running on those. With platform as a services, you only take care of the data and applications, and in software as a service case, you just use the service as is, and you are not really responsible for that much. So this balance of responsibility also ties in together with security. Any self-respecting cloud provider, be it Amazon or Google or Microsoft, provides you with, well, they share the responsibility of securing these environments with you. Yeah, depending on which service model you use, what the cloud provider secures and what you have to secure depends. And in case of Microsoft, Microsoft gives you all the tools and switches to enable to secure your environments. Is at your decision to enable those and configure these as you require. So, and I really like this analogy. If we compare different service models as look at those as car, then infrastructure as a service is the car you own yourself. You take it to the shop, you fill it up, you fix all the problems, you buy the insurance, all the associated things. With platform as a service, you just rent a car. Yeah, the servicing of the car always handled by the provider of the service, and you just, you know, use it. You decide what kind of features you want in that car, how much you're ready to pay, and you just use it as long as you need. Now with SaaS, you just take a taxi and trust that the driver will take you where you need to go safely and securely. And with PaaS, basically, when you as a developer use PaaS components, you can just cut to the code. You don't really have to think about managing the infrastructure. Who takes care of that? You just you're limited in what you can do in some ways, and that's kind of the balance between the control and responsibility. But you can be productive by focusing just on the code and the logic that you do, and not think about who will actually operate that, because that's the responsibility of the cloud provider. And there might be some limitations which you have to live with, but you know, then again, you have to decide what is more important to you, to manage all the stuff and have a better control of what you can have on your virtual machines, for example, or relinquish some of that control and move away and just focus on the logic that you write. Any questions on this so far? Right? You will probably stop me when you have any questions to ask, right? Great. So let's talk then more about Microsoft Azure. Microsoft Azure is, well, Microsoft's public cloud service. It's productive, hybrid, intelligent, and trusted. And let's take a look briefly at all these aspects. So Microsoft has a global presence. There's about 54 regions at this time. Microsoft has built 8 new regions this year. First to have regions in South Africa, United Arab Emirates, and there's most recently the ones that were opened were in Norway. Yeah, so there's quite a few peering locations and edge sites from which the content can be gotten. Well, basically think of the edge sites as CDNs. And Azure has an extensive networking infrastructure built to ensure communication between the data centers within the regions and between the regions. Each region and each data center within that region is connected by 2 lines. So that's quite a big network that Azure has built. And in some cases, the optical cable going under the ocean is built together by Microsoft and Facebook and some other company, I forgot. Yeah, so there's a big and strong networking layer beneath this. So let's talk about the physical infrastructure. First, the concept of geographies. Yeah, that's a discrete market with 2 or more regions, and kind of the main separator here is the requirements for compliance and data residency. So more and more we see that that these regions are country-based. So you are under kind of the same umbrella of compliance requirements. So your data doesn't leave a specific country or specific data compliance requirement set. So you don't have a region that consists of data centers being in one data center being in EU, another one outside of it. Yeah. Each region consists of 1 or multiple data centers, and their network connectivity between the latency is less than 2 milliseconds. And there's also the concept of availability zones, which protects you and your services that are running there from an outage of a region. So the availability zone spans 1 or multiple data centers within a region, or multiple regions in certain setups and locations where that's possible. Yeah, and that's basically to ensure that your service is available against situations where there's a data center outage. Yep. So how these data centers look. That's the data center building 3 and 4 in Dublin. So number 5. And that's 3, 4, 5. 6, 7, 8. And a whole bunch of space to build some more. So in case of Ireland, there's quite a lot of data center buildings for Azure region of North Europe. In Singapore, where there's less space, the data centers don't go wide, but go up because there's less land to build the data centers on. Azure is also a trusted cloud service provider, and that's been verified not because Microsoft says so, but because a lot of compliance certificates, at this point about 90 have been acquired by Microsoft, and this list keeps getting renewed. There's a Microsoft Azure compliance page where you can find which exact certifications have been granted to Microsoft and what they exactly mean. Oops, sorry. Yeah, and Microsoft Azure does not only work with Microsoft technology stack. You can take and use whatever you need to be the most productive. Long gone are the days of Steve Ballmer, who said that Linux is a cancer. Microsoft loves Linux, and they actively show this by being one of the biggest contributors to Git. Yeah, so you have support for a whole set of distributions for Linux distributives and for BSD as well, quite recently. Well, that's the BSD part comes from Hyper-V now supporting BSD networking stack. So, yeah, and there's, of course, quite a few, well, like you have to think about both the core infrastructure services, advanced workloads, and the tools being as a bundle together to ensure that you can be productive with the resources. So on a high level, there's a high-level overview of some of the Azure services available to you as a customer. In total, there's more than 110 different services. It's impossible to know each and every one of them and what they do in detail. Typically, you have to think about Azure and the products. Each product is developed by a separate team or teams, each working in agile fashion, meaning that each service may have updates every week. So it's quite impossible to keep track of all of them unless you work with them on a daily basis. However, that keeps life interesting, that you have to, every half a year, you might work with a certain technology and discover that the limitations that were there half a year ago are no longer there, or pricing has gotten more attractive. But the two of the things that I would like you to pay more attention is the security part and the management part that ensures all the nice-to-have features that you might want to have and wouldn't want to build yourselves, because the investment to do so would be quite significant. And Microsoft has long gone on promoting the fact that they actually, well, give us the services that actually use themselves. So kind of eat your own dog food and then share these services with the customers. A great example is the Service Fabric, for example. Anybody has heard about Service Fabric? All right, 2 people I work with. Anybody else? All right, some guy from Microsoft. All right, never mind. We'll touch that briefly. Okay. So if we look at the architecture part of Azure itself, there's the Azure infrastructure on which a hardware manager is ran, through which the Azure Fabric controller communicates with the infrastructure. And on top of that, we have Azure Resource Manager, which is a service for managing and provisioning Azure services. And it works with Azure Resource Manager resource providers, who in turn, through the Fabric controller and then through the hardware manager, actually provision the services for you. And you can utilize the power of Azure Resource Manager through Portal, CLI tools, Shell, SDKs, or ARM templates themselves. So the Azure Resource Manager is globally available, so it runs the same way in every region, and you provision the resources the same way everywhere. Yeah. So, and to manage these resources, as I mentioned, you have Azure Portal, Azure Resource Manager, templates, and command line tools, as well as SDKs, which are built for a lot of different programming languages. Anybody of you actually using Azure on a daily basis, besides the people I work with or have worked with together? Raise your hands. So who's totally new to Azure? 3 people. There's a whole bunch of no voters. Excuse me?
What was the second question?
Yes. Alrighty. So, Microsoft Azure Portal. Pretty neat looking if we compare with some other cloud service providers. Really neat and quick and easy to deploy your services whenever you need them by hand, and not a very convenient way to do it in production. Yeah. For that, you could use either command line tools and written scripts to provision your resources. And there's now an Azure Cloud Shell, which you can use just your browser without anything installed. So you can basically take any machine and operate your cloud resources and do provisioning on them or changes in the state of them. And Azure Resource Management templates. So there's the Azure Infrastructure as a Code solution for provisioning various resources, and allows you to group the resources together and the deployments together as well. Yeah, you're not limited to deploying those in to a single resource group or a single region. You can have all your, no matter how complicated your deployment, you can write up a Azure Resource Manager template to do the deployment of your environments, and then use one template for multiple environments, and basically with parameters control where you deploy what. so you can operate in real DevOpsy way. Okay, you can't really see this one. We'll take a bit of a closer look on the ARM templates after I'm done with slides, if there is interest, of course. Yeah, but this is how it basically looks. You have parameters, variables, resources you deploy, their properties, dependencies, and outputs. Dependencies allow you to specify in what kind of order the resources are provisioned. So you have a pretty neat control over how you work with these deployments. You can obviously use the outputs from different deployments as inputs to other deployments and control it like this. And the products we work with in Visma and hosted on Azure, we use the infrastructure as a code in all of them to control the deployments. Yeah. So benefits of applications in cloud. Well, first of all, agility. You can work and make changes to your applications a lot quicker. You're not limited to sending a disk or installation to someone on-prem who does it themselves. You can, if your setup allows you and the application is developed in the right way, you can do the deployments for all the customers at the same time. And you can in more agile fashion work on your applications. Scale. Obviously, one of the big motivators to switch to cloud is the ability to scale the resources beyond the limits of what would be normally imaginable by your data center or by regions. And you can easily set up multi-region setups and configure these resources to scale depending on either the demand or expected demand, so you don't ever overspend or provision too little of resources if you require. Security. Security is a big thing. When I started working with Azure and cloud in general, security was a big concern for people. That was the blocker for going to cloud. And now we see that people have realized that, hey, actually, to match the investment the cloud providers do in security ourselves, it's way too expensive. So we can rely on what's been built by the cloud providers and use the security tooling and features they have built. And so the security now is an enabler for hosting applications in cloud. And that has been a big change. And I'm really happy that we don't have to spend time talking about customers about, is it really secure? Well, it depends on whether you take care of your part of the responsibility. If you remember, we talked about shared responsibility for the security as well. Microsoft and other cloud service providers give you the tools to secure your environments. But whether you use them or not, that's on you. Azure has a Azure Security Center service that allows you to, or rather suggests you what you need to do to improve the security stance of your resources and your application. And I'm sure that other cloud providers have a similar service as well. So innovation, you can easily add intelligence and new interesting and valuable features to the applications by reusing the services that are provided by or given to you as a user from cloud service providers. So you don't have to build them yourselves. We'll talk about cognitive services and the powers that they enable you to add to your applications. And to build those yourselves, that will be also quite a bit of investment to do. And obviously, changing skill set. You get to learn new stuff. You have to think differently about how you develop applications. You apply new patterns and new ways of thinking. And you also kind of have the chance to migrate your old applications. We'll talk about that shortly. But yeah, these are the kind of the benefits I wanted to outline about applications cloud. So what are the options then for existing applications? Yeah, so you can either migrate, which is rehosting, or rehost the application or lift and shift it to cloud. You can refactor it or re-architect it to use smarter components, or rebuild it from scratch. Or if you're a customer and you have a choice whether to have a classical client-server application that you have to install and maintain on your machines in your data center, you can just replace it with a SaaS solution that takes care of all the operational things, and you can only focus on using the product. Yeah, so migration to cloud, or rehosting, or lift and shift, as it's called. You basically focus on you take what you have and you deploy it on Azure instead of managing yourself the hardware for these machines. So in cases where your hardware is running at end of life, instead of purchasing new hardware, having contracts, having people that have to operate these environments or the physical parts, you can just offload the physical part and just take care of the operating system part. It's by far the easiest way how to start using cloud, and a lot of enterprise customers first go this specific route, where they just use virtual machines in cloud rather than virtual machines on-prem hardware. Yeah, and the core technologies used are virtual machines and virtual machine scale sets. Azure helps you with build services that allow you to basically migrate any workload to Azure. There might be some limitations in older operating systems like Windows Server 2003 based ones, but other than that, there are ways of doing that with the tools that Microsoft provides to you. With Data Migration Assistant or with Application Migration Assistant, that's one is for the databases, the second one is for applications, which allows you to investigate whether you can use a PaaS service for that database, or your database, for example, needs to be hosted on a virtual machine. And if that needs to be hosted on a virtual machine, you can do the data migration using that tool. One great advantage, for example, if you have Microsoft SQL Server, the pricing of the virtual machines in Azure, if these are based on Microsoft operating systems, also include the license price. So for example, to migrate a SQL Server, you might save up to 7 times the cost of purchasing the same license on-prem. So the cost saving part is also a big factor of why even just going to virtual machines in Azure is an efficient way of saving companies money. Yeah, refactoring, that's you basically take a look at your application, you figure what you can improve, and you kind of keep the code base itself, but not changed or changed minimally. You investigate the possibility of using PaaS resources wherever possible. You use tools to investigate whether your database can be migrated to Azure PaaS service as is without any changes. You just change your connection string and use PaaS service. And in a lot of cases, that's possible. Now, for example, the same database example, Microsoft has also quite a bit ago announced the SQL Server managed instance option, where you get a PaaS with full Microsoft SQL Server features without sacrificing the ones that you would have to sacrifice if you go to the typical PaaS solution. But you use what you have. You don't really change the code base, and you just rely on containers for portability. Yeah, and yeah, containers are used for quick migration. There are tools that investigate the virtual machine configuration and generate Docker image. And you can use Azure Container Registry, which is a service for hosting your private Docker or container images, rather, I would say. And then you can deploy these from there, either on-prem, on Azure, on any other cloud provider, if you would wish. So Azure also has quite a bit of container options. So I mentioned Azure Container Registry, which is a private, container registry. There's Azure Kubernetes Service PaaS service that takes away the need for you to manage control hosts. Azure App Services, which we'll talk about a bit more in detail, also has support for containers and can be quite efficiently used for quite dense deployments of containerized applications. Azure Container Instances is a way of hosting your container any container basically just by specifying how much CPU, RAM you will require. Basically, think of this as a dedicated virtual machine running your container image. Azure Batch for high compute processing tasks, where you split out tasks, basically map-reduce tasks. You can use containers to easily configure the applications that you have to run in these containers that will perform your map-reduce tasks. And Azure Service Fabric, which is Microsoft clustering service for hosting microservices-based applications. Azure Service Fabric is one of the services that Microsoft is using themselves to host, for example, Azure SQL Database PaaS service. Now that's made available for us, the end users, and has the full lifecycle management for the services, for spinning up, controlling their lifecycle, naming services, scale, self-healing, rolling updates, and all these nice features. Yeah, and re-architect, you rework how the application is built to use smarter components. You replace what you have and do rewrites on code, and you utilize platform as a services, microservice-based approaches, containers, and serverless services. Yeah, and you can deliver more new capabilities and also modernize your applications. Yep. So, microservice fans in the room, raise your hands. One guy, same guy, right? Yeah, so basically every microservice is individually built and deployed, can be deployed by different, developed by a different team, communicate through exposed APIs. You take whatever language suits you best to develop the functionality that you need. You just expose your connection and hide what's underneath it. Yeah. Not gonna go into too many details. And rebuild, basically build your application from scratch. You redesign, you realize, well, there's so much legacy stuff in there that makes more sense to redo the application from a get-go, re-architect it from scratch. And typically, if we go back a bit to the initial slide on what to do with the applications, the enterprises tend to go this route left to right. It takes, depending on the size of the enterprise and how ready they are to move to cloud, the speed differs for moving from left to right here. So any questions on this so far? You know, there's some prize bags still to be earned.
Yes, you were talking about ARM templates and Docker files. Could you elaborate on how would you recommend using them in real life when moving like existing infrastructure that uses, for example, Docker for Devops and such,
yep,
and moving them more in Azure, employing ARM templates?
So I would start by defining the infrastructure on which the containers will be hosted first, in a form of template. Yeah, you template out, and from a practical perspective, typically we also, even though we work with ARM templates extensively, we do it initially through portal. You click through all the things, and the portal actually exposes you the template for each resource deployment that you do through portal. Because the portal actually communicates through ARM, so every deployment you can get the template as an output. So I would start with defining the infrastructure and figuring out where you will host that Docker container first, build out that infrastructure, and then I would configure, no matter which DevOps tool you use, to deploy the templates and then deploy the container on that infrastructure, no matter you use Kubernetes or you use virtual machines to host Docker containers, or you use your own private registry, or you move to Azure Container Registry, because you can do all of that. And that would be the starting point. Define infrastructure, well, after you figure out on what you will gonna host the containers. And as I mentioned, there's 5 hosting options. And then you configure the deployment pipeline to first deploy the templates and then the Docker container images. Depending on the service that you use, it either has a template itself. For example, the container instance one has a built-in functionality where you provide just the credentials and URL to your image, and it provisions it. Different services have different ways of handling that. Kubernetes has their own definition where you define the pods based on the images. You provide the URLs from where you get those. And that would be the approach I would take. Does that answer your question?
Yes, thank you.
And I think the gentleman has also deserved a prize. See, questions equals prizes. Anybody else has a good question? It's a lot more interesting to talk when there's actual feedback. Does ARM has the same functionality as the portal? I'm sorry. No, those are 2 separate different things. Docker Compose file defines a container. ARM resource template defines Azure resource deployment as an infrastructure as a code. So in a sense, yes, you write code to define something you're going to run. But in Docker Compose, you create a Docker file. With ARM, you create a configuration of your resource deployment. Does that answer your question? Great. Judges decide price or no price. I'm okay with giving out a prize for a question.
We have only 3 left.
So okay, the level of question has to go up now.
Can I?
Sure.
So you showed the path from migrate to rebuild. So
Yep.
what's your experience in this sphere? So do you think there is a way in this path to cheat?
Yes, absolutely. Absolutely. I mentioned enterprises usually go left to right as is, because like large enterprises are usually scared of just doing that jump to PaaS. Worked with a company, I will not mention a name, a big logistics company, one of the biggest in the world, possibly. They said, we don't trust PaaS because it's not secure. And you can't do anything about that. So they jumped to virtual machines. Now they're switching slowly over to containers. 3 years later, after we worked with them, I don't know whether my colleagues from ATIA still work with them or not, and in what capacity. But now they're slowly moving to containers. Yet, ISVs, I previously worked with also with independent software vendors who have that on-prem solution, which they deliver updates every half a year or a year. They realize, hey, we are losing customers to companies that provide cloud native solutions, or what we used to call fake SaaS, where they actually automate the deployment of the infrastructure, but in reality, each customer has their own environment, but to the end customer, it looks like they're using SaaS software. And these companies also kind of diverge in their path, because some of them just go directly and say, well, we're going to rebuild from scratch. But that approach has a problem, because A, you have to maintain the existing application, because otherwise you lose customers because you're not releasing any new features, any updates. Or, stop doing that and focus just on the new one, and you risk losing customers. Or the other option being, hey, hire another team that will focus on developing the new product while you manage the old one in parallel. Depending on the size of the company and depending on the strategy they take and how big their competition is in which space, they might decide to go slowly or do with the re-architecting part and jump to containers straight away and not do IaaS. But most of the ISVs also, where I've seen, and that's been about 50 different customers over 3 years in the TIA group, have gone initially to either IaaS or containers, and only few of them have gotten straight to the PaaS serverless path. One of the companies the most successfully applying, kind of going down that route, in half a year managed to rewrite their e-doctor system in Norway to something based on Azure Service Fabric. And for the front end, for a time being, they had to use RDS deployment of virtual machines because their front end was from beginning of 90s. So they were not mentally yet ready to rewrite that from scratch. It's all about strategy, the size, the number of customers you have. Because like when you think about this from a scratch, when you have to develop application from scratch, you don't have to carry that old baggage with you. But when you have that baggage and customers that come with that baggage that rely on it, you have to really think about two things. Well, how do I solve the problem of building in parallel and doubling my cost versus not developing anything and losing the customers potentially? And the second thing is, how do I migrate all these different versions of on-prem application when I have developed that new software in cloud? What do I do with existing customers? Internally, we had a product called Application Manager. Some of the people here will know about that one. The number of versions running for different customers in different environments was, I think, 217 versions of that same application, because some companies were just not ready to update every time they got the update. So when you build that new one, the second problem you have to solve is how do you migrate those existing customers to your new solution? If they're ready to do so, first of all. All right, that question definitely deserves a prize. That's a good one.
I have a question.
Sure. The floodgates are open.
So far, you have been talking about existing companies, existing enterprises. Let's say I'm a startup entrepreneur and I would
Yes.
like to implement my own startup company. Yeah?
Yes.
Would it be beneficial for me to use your services? Are there any let's say X users free?
Yes, there's actually quite a lot. Most of the Azure services, and I actually really hoped that this question will come up because I really thought about the answer for this one. Most Azure services have some free capacity, with the exception of storage and virtual machines. Those are the problematic ones. But I really recommend, if you're thinking about building a new software, don't go that route. Go with PaaS services. There's for app services, we're going to talk about tiers and sizes. You have a free tier that gives you free usage. For serverless, you have quite a lot of free usage. I will demonstrate a demo that's built using free components that does not cost anything for months, basically. And besides just having a low price for services just to get started, there's also quite a few programs for new entrepreneurs. I'm not an expert in those. For that, we have to ask our Microsoft colleagues or ex-Microsoft employees about the paths that allow you to get some free credits from Azure, some support programs that allow you to do that. But basically, there are free tiers for most of the services that allow you to build and test and even use these services for a small set of customers. So you're not in that squeeze where you have to invest the money in an idea you're not sure is going to fly, and then it goes out of your pocket. You can try things out with for free or with a very, very low cost. And if they work out, then you can eventually switch over to paid service. That applies also. I will demonstrate my demo and how the deployment goes. It works not only for Azure.
This one, Azure for free.
Oh yeah, that's a good pointer. But there's these are I'm not sure about this one. Maybe someone can comment about Azure for free, whether this is specifically aimed for entrepreneurs and startups, or this is specifically for you developer doing your test work on it. All right.
But for startups, I think Microsoft revamped the program a couple of years ago, and you just basically get a bunch of legal companies doing tech products, and then you get a bunch of free credits. But now you have to be going for some accelerator. So we have a bunch of startup accelerators here in Baltics as well. So if you join them, then you can also apply for this Microsoft Startup program, Microsoft Startup.
Yep.
You can search it and
Thanks. That was real helpful. Does that answer your question?
Oh, yeah.
Sure.
Yeah. You have been talking about migrating applications, but what about migrating data? If like I have huge enterprise with like tens of terabytes, petabytes of data, is there a way like to quickly get the data to the cloud?
Quickly? Define quickly. But I mentioned actually in the migration part, there are data migration assistant in particular, if we're talking about databases, to do this migration. Depending on the size and networking limitations that you may or may not have in place, there are various options that you might do. There's the data migration way. It implies a downtime. There's the other way of actually using configuration that writes transaction logs in parallel also to on-prem and Azure. That's kind of the slow and seamless transition. And of course, you can just make copies of your data to disks and ship them over to Microsoft, and they will import this to you. Or you could use a service called ExpressRoute to connect your on-prem directly to Microsoft backbone, or you could even use a product called Store Simple that uses tiered storage to cloud, and that could also be used for migrating scenarios. In some cases, there are limitations. Like we would need to specifically look at that particular case to decide which approach would be better. But the thing is that for every problem you might encounter, Microsoft Azure may have one to multiple solutions to it. Each solution has their own limitations, price points, and features. And what works in one case might not work or be efficient in a different case. Does that answer your question?
Yeah.
Great.
I have one.
Sure.
Let us assume we are having some legacy application and it is having
Let's.
multiple 30 plus APIs.
Yep.
So I want to modernize that application as part of putting this APIs as part of the API management. Do you have some particular approaches to in that situation?
See, you already mentioned there's a service called Azure API Management, which allows you to define a mid layer between the what's calling the APIs and what's in the back, and then you can use the strangler pattern to switch over from your current API to one that you migrate to Azure, which you host either as a function app, as a logic app, or anywhere else, depending on particular one. And I would the approach that I would suggest would be to take something lightweight and easy, just move them one by one, not to go the big bang way, but just tear one out, see how that works out. Yeah, thanks. You had a question there, gentleman with the glasses.
Yeah. What is the difference of applications are running on virtual machines rather than Docker containers? Do you understand the virtual machines are dying off?
I wouldn't say that they're dying off. With a container, you're just sharing the kernel, and you're basically virtualizing the process. With a virtual machine, you're virtualizing the whole operating system and everything in it. Yeah, and I wouldn't say that it's basically comparing apples to oranges. So that's the best answer I can give you to this question. Anything else before we move on? Okay, so kind of lame to go this over a bit. By the way, we haven't envisioned to take any breaks. If you would like to have a break, all of you, then we can have one. But I see someone nodding, somebody saying nay. What's the consensus? Organizers, guys, what do we do about that? We go on until last person drops to the floor? Sure. Yeah, so there is a thing called app hosting decision tree, which basically provides you a guidance on what to choose in which scenario. I will not go into details into this. The main thing for you to think about is to remember there is such a thing, if you will Google that specific name of the, or rather the, what do you call the subject of the slide, you will find this picture. But the main message here is that no matter your hosting needs, there is a solution in Azure, or multiple solutions that may or may not work for that particular case. All right. So Azure App Services, that's Microsoft's PaaS service for hosting applications. Kind of typically one of the first ones that developers like, and I would encourage to play around with. Yeah, it's enterprise for hosting enterprise-grade applications, fully managed platform, and high productivity development. Basically, you don't really have to focus about what happens in the backend and who operates that. You just focus on the code that you run. So about the features in general for the enterprise grade, there's the global scale, there's the hybrid support for networking, meaning you can actually connect your web app PaaS service to a network to allow your virtual machines to communicate with that application exclusively. This might be something you do as a proof of concept or because of a security requirements. You can actually limit the access to the app service just from a specific virtual network, which may or may not be peered on-prem. And this is how you limit access to it only from controlled networks. Besides, of course, of having the possibility of configuring IP address ranges or DNS names from which you can actually communicate with this particular app. There's Azure Active Directory integration, as well as integration with quite a few of popular identity providers. Through a feature called Easy Auth, you can configure authentication that relies on either Gmail, LinkedIn, Facebook, Twitter, as an examples. Just by a couple of clicks of buttons, you can enable authentication using these providers. If you have an API key to the specific identity provider, you can offload the authentication part of your application to a trusted identity provider and not have that in your code base. Just focus on authorization or giving rights when that user has authenticated. There's a security and compliance features. Of course, some of them I mentioned, both talking about the security and integration into networks, as well as Microsoft's own DDoS protection system that's in place for all of the services that they offer. Of course, there's also the premium tier, but we're not gonna go into details on that. The fully managed platform, it's high availability. It gives you 99.95% availability out of the box. Your operations costs are also reduced because you don't have to take care of the hardware. That's the responsibility of the cloud provider. You have a built-in backup and recovery tools, and if your app configuration settings contain a link connection string to your database, which I wouldn't kind of suggest doing that particular way, the backup also will include that database snapshot at that point in time. Yeah, and built-in auto-scale and load balancing features, which means that you can configure your application or rather app service to scale out depending on loads coming in, the date, or various a combination of various aspects. You can use most of the popular languages. You're not limited to the .NET stack. Only you can do staging and deployment. So basically, deployment slots are also an option. They run as a parallel application. You can do deployment to your staging slot that has staging connection strings to your staging database. You can then, when you validate and test the code that you've deployed, you can switch over the slots. And if something goes awry, you can switch back. This enables testing in production. And there are also quite a few testing features that are added in there. For example, the redirection of certain amount of traffic to one or the other slot. So you can actually make sure that some of the users go to your testing version of the application. Yeah, on the app services, you host web apps, of course, functions. We'll talk about functions a bit more as well on a consumption-based model where you only pay for execution. Mobile app backends and API apps. They used to be separated out as a different service offering, but basically under the same umbrella. Not the case anymore, but basically this is the intent that you can store there. So platform support, ASP.NET, Java, Node.js, PHP, Python, Ruby, for sure. For different versions available, we have to check because these are added periodically. This is where the control versus the responsibility comes in. You might not have your favorite language supported on the app service. And well, tough luck then. In that case, you have to either use one of the languages that's supported, or you have to use a hosting environment in which you have to have more responsibility of managing these parts yourself. So that's always that decision, whether you live with the limitations of a PaaS service and get the benefits that they offer, or you really stick with what you know or what you have to use and then deal with the additional pain that the ownership of that particular type of resource comes with. So there's quite a few features. I'm not gonna go through all of them, some of which I mentioned, the most interesting ones. These apps that we deploy are hosted on app service plans. App service plans basically are the resource boundary. You can host multiple apps on a single plan, and they have to be located, and each application is hosted on a single plan, and they share the resources of that particular plan. Yeah, and there's, of course, as mentioned here in the slide, there's the free tier. Free tier allows you to run 60 minutes of compute a day for free. Well, you can really play around and not pay a penny for playing with these. Yeah, and so underneath these app service plans are provisioned as well. These are usually the pre-provisioned already. So when you deploy an app service plan, they get deployed really quickly. And depending on your requirements, you host one or multiple apps on that same plan. Yeah, and when you have multiple instances of the application, or rather multiple instances on the plan, you have a multiple copies of the same applications running on each of those. And the implication here is that your applications have to be stateless because there's a load balancer in front of the app, and you don't really know which instance the customer will hit. So the state needs to be stored somewhere off the particular application. So there's the concept of scale up. Anybody knows what that means, scaling up?
More additional instance.
No, scaling up means increasing the power for the existing instances. Yep, that's correct. Scaling out is adding more instances. Another question to you guys. What do you think is a better approach, scaling up or scaling out?
In the middle. Depend on the application.
True. But the main thing is that scaling up is a lot more limited. There's only 3 levels on the app service plan to which you can scale up. That's the size of the machine. Scaling out can go up to 50 different instances of the size to which you can scale up. So you're quite, the size can be quite significant for the resource pool that you apply for your applications. Yeah. And yeah, one more thing. Yeah, typically there's, well, 2 more things. There's a combination usually in use, both for scaling up and scaling out. And when you have a set of instances, when you scale out, you basically double, triple, quadruple the cost of the particular app service plan. And for applications, in this image, you can see that every instance has the same copies of the same applications. Does not have to be the case. You can actually force that a certain application takes the whole instance up. When you identify that certain applications just eat more, so you have the noisy neighbor problem, and there's quite a bit of automation available out of the box that allows you to move the app that's consuming a lot of resources away from an app service plan that's shared between different applications to a dedicated one. And this is how you achieve that users don't really suffer the performance issues in case a certain application demands a lot more resources than the rest, or you need performance for a specific application to be, well, bigger requirements are there. So auto scaling, you can configure automatic scaling out for the app service plan, depending on various set of rules, metrics, schedule, a combination of those. And you can configure the limit when they scale out, when they scale down, so you don't really have to go in and manually manage the number of instances running. You can automate this with rules to predict that, well, I'm running an e-shop and it's a Black Friday, so we're going to use a lot more resources. I'm not sure how much, so I want this to auto scale, but to a limit because I don't want to break bank. So all these possibilities are available to you out of the box. Imagine scaling your application on-prem. Wouldn't really work. You would only buy bigger hardware or would buy more of it, but you would have to predict beforehand how much you will need, and usually you would take a reserve, purchase more than you actually require at that point, because at some point you might need more. So you either underutilize or overspend, or you underestimate the load that you will require. So this is also kind of, we talked about the scale as one of the benefits of having application in cloud, and this is kind of this auto scaling thing that allows you to kind of let Microsoft take care of the scaling problem for you when the demand is there, is solved with auto scaling thing. So deployment options. There are manual deployment options. Currently, you can actually manually deploy from Dropbox, external Git, to OneDrive, through FTP, and continuous deployment tools that are supported out of the box are Azure repos, GitHub, Bitbucket, and local Git. All right, now let's talk about serverless. Anybody has any idea what is serverless? And what's the difference between serverless and PaaS? I guess stop raising their hand. You get tired real quick. I know you know the answer. Chirp, chirp. So serverless basically is an abstraction away from servers. Even with the PaaS resources, you kind of had to think about scale. With serverless, you forget about all of that. You don't really care how much you need to provision beforehand. What are the things that you need there? It just runs. It's event-based, and you're built per the transactions for the resources they use. Either that would be gigabytes of RAM per second used, and with functions we'll discuss shortly, you get quite a lot of those for free. And yeah, so basically abstraction from servers. You don't have to think about the scale. Yeah, you can create instant event-driven applications and host, for example, APIs that run only when triggered and only pay when there's actual execution. That's also a big difference with the PaaS service like app services, where you kind of have to say from a get-go, yes, I'm committing this amount of money to have this resource run at a certain capacity. This is how I also control my spend. The functions we'll discuss shortly can also be hosted on app service plan and also consumption-based plans. And this is the difference where you decide whether you're going to pay per use or you're going to just pay a committed amount of money for that particular service. You want to be in a closer control over your spend. Yeah, so the benefits of using serverless is you just focus on the problem at hand. You don't really think about all the scaling part as well. It just goes out of the window for you. You have shorter time to market. You can develop these also in Portal if you want to, and just by doing either a drag and drop designer like for Logic apps, or you can just write the function code in a web page that compiles whenever you click save. So you instantly see whether this would work or not. And yeah, and quite simplified starting experience. You can choose your language, you can choose your triggers, you can reuse bindings to other resource types, so you don't have to write connection logic. You just reuse binding for Microsoft, Microsoft or third-party service just by using these. So you don't really need to think about, you only think about the logic, and you don't think about how you will realize a code to, for example, connect to an email client, get the emails, insert something in a SAP application. So Azure Functions is, well, basically event-based serverless compute model where you deploy a code as part of a function that runs when a certain event happens, no matter what the trigger. That might be a time-based trigger, that might be an HTTP call, that might be a file inserted in storage, that might be a database record change, anything basically that you would like to do. You can run and develop this locally. You don't even have to host anything on Azure. You can get the Azure development tools and Azure Functions as part of those, and develop locally and deploy to cloud only when ready. Yeah, and you can host this either on consumption plan or app service plan, as I mentioned. And actually, you can run Azure Functions runtime also as a container. So you can actually write your function, containerize it, and use it wherever you want it. Now, the sample scenarios would be web application backend, some continuous tasks, or a task when an event happens. For example, an image is uploaded, or a change in a profile is made, or a notification is pushed. IoT connected backends, bots, file processing, stream processing, automation of certain tasks. For example, deployment cleanups, scaling of resources. Like if we talk about the app service plans, I talked quite a bit about scaling out and scaling up not being available out of the box, but you could automate scaling up or down at a certain times when you know that, well, this makes sense and my application is not really stateless. At certain times I would need more resources. You could automate scaling it up and scaling down when you no longer need the functionality. And given that your application does not go down when you do that, it's a nice way how to automate a task you would otherwise do manually by using an Azure function and making an API call to the backend. And you don't even have to authenticate that, because you can use managed identity for that resource. That means that you don't really have to also write the code to authenticate against Azure and have rights to operate with these resources. Oops, jumped there. So it's fully integrated with Azure ecosystem, meaning input and output bindings to different Azure services, which means that you don't have to write the connection logic to it. You can use the binding and just focus again on writing only the useful code, because the code for connecting to Azure services has been written already by developers in Microsoft. You can both subscribe and publish to EventGrid. So this also allows you to react to different events and have multiple consumers on a single event. I'll discuss that kind of in more detail, and have it also as a part of a logic app where you use, well, we'll talk about logic apps to make more sense, where you extend some logic that does not have a connector written by somebody else. You can include this as a part of that workflow, right? So event grid. That's a fully managed event routing service from Microsoft that allows you to, in near real time, both receive and push events out to the consumers. And the great advantage of this is that instead of your consumers of those events actively polling for event grid, hey, is there a message for me? Event grid actually pushes this message directly to the consumer whenever there's an event to which they're subscribing to, which means that you actually react in real time whenever an event arrives. And your single event can have multiple subscribers that run in parallel and do multiple different things. Yeah, that's a backbone for event-driven computing. Yeah, so, and this allows you to manage all events in one place. We work with an integrations platform that either reacts when there's a time trigger or certain event, and we have the coupling of publishers of certain events from subscribers. And for a single event, you have can have multiple subscribers that react on events, either from a set of existing services or custom topics, which means that you can write your own logic that sends an event out on which the consumers will react. Yeah, and you can ensure reliability with this because you get 99.99 yes SLA on this, and it can handle tens of millions of events per second because it has an exponential retry when either the service that's receiving these events or the event grid itself is busy. These will be retried exponentially up to 24 hours from the moment they're received. So you kind of guarantee that this event will be delivered where needed, if of course the consumer of the event is not down because of a different reason. Yeah, so you kind of move away the reliability from this one. So the use cases, serverless apps. Whenever there's an event, you instantly trigger consumption. For example, as you can see in the architecture drawn there, whenever there's an image uploaded to a blob, an event grid triggers a function that does some changes to that image. You can automate operations. That's one of the examples that I mentioned was scaling up of an app service plan. But you could be clearing out logs, removing old records from various things. You might be calling automation to ensure that tagging is in place and people who are responsible for resources that are not been tagged are notified, hey, you didn't tag that. So you can build a logic on that. And you can, of course, use this to integrate applications. So whenever there's an event, meaningful event happening, for example, if we take the operations case, if a service goes down, then you can use this to notify multiple streams that need to take care of this. Either create a ticket, send an email, send an SMS, and route and handle these events as required. All right. No questions so far? I'm asking this to find out whether you're sleeping with your eyes open or not. There's still 2 prizes to be won.
I have a question.
Sure, John.
So what would be the recommended amount of instances running in production if you host a web application on app services?
It depends
Why?
on the utilization and how much you're ready to pay and what speeds you require and what's your expected usage.
I was more interested in, so obviously someone's doing maintenance in the back end, or
Yes.
yeah. So how would your application handle that if Microsoft is patching something in the back end?
That's a really good question, actually. But Microsoft seamlessly transfers your app. It's actually when it's running a multiple instance copies of your application. So when the hosting host that's hosting one of them goes down, there's others in place to do that. So with virtual machines, you're actually limited in that case, because virtual machine, if you only have one instance of that virtual machine, unless, of course, you're using the premium storage, it will go down whenever that event happens. with
Would that be the same the case with running one instance?
No.
So you would run more than one instance or just one instance?
You can run just one instance and be fine with that in that region. So it does not protect you against the regional outages. There's a ways and how you build out and think about those things there. Any other questions? Sure. In a sense, it is, yes. Except it has quite a lot more connectors, and the power apps are more oriented to the business user, than these are more developer.
Yep. And actually, let's say, power apps are built on top of logic apps as well. So, but they are as well as Carlos mentioned, more meant for power users or citizen developers, and the logic apps are more meant for developers. You have a lot more developer steps, which people who are not engineers could find confusing.
So is it possible to integrate power apps?
Do what?
Is it possible to integrate?
Yes.
Indirectly, for sure.
Yeah, and one of the things, let's say, which is interesting addition, if I'm hijacking you a bit.
Go ahead.
So it's that, let's say, if you want to be super secure, for example, and you don't want to use, let's say, Power App on-premise gateway, which is the way how you, let's say, like kind of, let's call it like proxy thing, which you deploy in your local environment from Power App. If you don't want to use it because it uses Azure Service Bus, and Azure Service Bus is great, but it does not support bring your own key. So you cannot encrypt data at rest with your own key, and some customers may want to require that. So workaround around that is using Azure Logic Apps in integrated security environment setting, where it has has limited amount of connectors you can use there, but you can essentially use it as a connector for your on-premise environment with only for one-to-one connectivity scenarios. And so that's kind of this Logic App becomes a connector for your Power App in a way. So that's kind of how you can, let's say, work around some limitations in real life. Yeah.
In that particular case, if I may interject, I would rather look at the Azure Relay service for that connectivity to expose your connection and extract data from a certain solution.
To be fair, I have no idea how Relay service works.
All right, doesn't matter. It's basically a service that calls out to the. It's part of the service bus. It calls out, so it makes an outgoing connection. And
if it's part of service bus, it still then does not.
Well, you then encrypt this. You then encrypt this with your key on-prem rather than rely on the service to do the encryption. But all right, that's. Thanks for the interjection. So, Azure Logic Apps. It's basically a tool for orchestrating workflows, where you rely on connectors built by someone else and code logic, and you just focus on orchestrating a solution to the problem you're trying to solve. Yeah, and you can actually develop those in two ways, either through Portal or by using ARM templates. And you have quite a lot of connectors, not only to Microsoft stuff. So this again goes with the same benefit that we were discussing for serverless, that you only need to focus on what is the logic you want to build, and you can reuse the connectors built by someone else. You just think about how you solve the problem. What are the steps that we need to take? What are the conditions that we might have? And if you don't have a connector that suits the purpose that you need, there's a service that's not covered, well, then you include as one of the steps in your orchestration flow to call Azure function that will do the connection to the service not used here, or perform some actions not supported by the connector in place. And you can then return the output of that function back to the orchestrator, which, depending on what was the result of your action you tried to do, moves on, either terminates or moves on through different branches of that logic app. And this is really like this service has when it was released, it was called BizTalk Killer, because it basically is a serverless solution to the BizTalk problem, which was a service used to do integrations between various applications and orchestrate the flows. Yeah, and you can use Logic Apps to interconnect various different services and also have an on-prem data gateway to connect to on-prem and get the files out from there as well. There are some size limitations in place which might force you to go with a different approach. For example, use a data factory, which is more kind of data-oriented solution for ETLs. Yeah, but this is a great and a more extended way than Power Apps to do the orchestration of workflows. With Power Apps, you're somewhat limited in what you can achieve, and it's also more user-friendly, and you don't have the ability to deploy these with code. Yeah. Yeah. So you can learn more about these here. Yep. All right. How we are on time? Quite good, right? Okay, Microsoft Cognitive Services overview. Any idea what are the Microsoft Cognitive Services? Anybody heard about those? Except the usual suspects, of course. Close, you're actually really close. Because these are services that have been built using machine learning. Machine learning has been used to train algorithms. And now these trained algorithms have been exposed by Microsoft as services for us to consume in the spaces of vision, speech, language, knowledge, search, and labs. And this means that you can use a ready-made service to handle a business problem that you might have. For example, evaluating emotions of persons in pictures or in video, speech recognition, search, text analysis, Q&A maker, yeah, web search, image searches, anomaly finders, things of that sort, where you don't really have to think how you're going to build a model and train it to do that specific or solve that specific problem you have. And with these, you can focus only on the problem you want to solve and not how you're going to do it. Yeah, so it's super easy to use them. There's a REST API where you call the service, you provide the payload, whether that be a URL to a picture, a stream of data, and you get a response. And you can use any language you want and use the libraries already built to introduce these additional features to your application. And these are tested by experts, and there's quite a good set of documentation actually covering those. Logic Apps also have connectors for a few of these as well. Not all of them. For some, you have to write functions to extend the logic, or not extend the logic, but rather make calls that are not supported by connectors. Yeah, some real-world applications, world applications, sorry. Yeah, recognizing what's in the video, doing text-to-speech to either find a location with interconnection with a map service, or figure out whether a person is angry or not, or translate it to a different language and do a speech out. Do a language processing, or build a Q&A bot, which is also quite an interesting solution to the automating of a first level of help desk, for example, because that Q&A maker can actually parse your knowledge base and understand the intent of a question that's asked for the bot, and understand whether the information that you have in knowledge base actually solves that particular question. not just mapping directly one-to-one. You don't have to necessarily ask precisely the question that described in the knowledge base to get the answer to the question. It understands the intent. So you can formulate the question in various different ways. And if the intent of your question matches the one that's answered in the knowledge base, you get an answer from the bot. Yeah. And you can, of course, integrate the searches as well. Or you could use the language sentiment analysis to investigate whether the help desk professionals you employ are polite to your customers. Or you can join these two together, use text, speech to text, and then apply this to also analyze audio recordings of your help desk calls to understand what or how quality, what is the quality of the service. I know companies that have employed quality assurance teams that work and read these emails and recordings. You can totally automate that part and let these people focus on something more interesting. Does any of you, and this is a price-worthy question, has a problem that they think could be solved or guess could be solved with any of these cognitive service options, besides the ones that I mentioned? Driving? Possibly. Any other ideas? Sure.
I have an example and also a question related to quality. I've played around with Watson IBM.
Yep.
This same thing, computer vision.
Yep.
It's API, and I use it in a hackathon to recognize food items, to create an
Yep.
app that will recognize food items and actually will tell the calories food. That's for example an example.
That's an actually good example.
But the quality of it was quite poor. It's literally like 2 out of 10 very clear pictures it could actually recognize. Is there a way to estimate the quality of these services before actually using them?
Yeah, you can. There's a Microsoft Cognitive Services page where you can actually try the listed services here with the given examples. And there's actually a service that allows you to train your own image recognition algorithm, which you then, of course, the problem there is that you have to feed it a lot of data that you have labeled, and B, Microsoft will reuse that data anyways to train their own model on that. But yes, there is, first of all, there's free tier that gives you 1,000 calls per month with a rate limit of, I think, 10 calls per minute or something for free that you can use and try it out. Besides the portal that I mentioned, where you can just play with it without even that cost. So you don't even need an Azure subscription to get a cognitive services subscription on a free tier and try it out and see whether this is better or not. That would be an interesting comparison case. Any other ideas that a cognitive service approach would solve? 911 in a sense. All right. Which would be the mechanism you would use? You would either judge person by face in an application, or the sentiment of their voice, or what the emotion you detect. And then you would use a way to send over the location to the police, or you would make a call. You would translate the text where the closest recognizable location where you are is based on a map service, and do a text to speech to.
The code is telling everything, and the machine is recording that and converting, sending
directly to the right services fire department.
Yeah, that's nice, but I have a little doubt that our local services here in Latvia would be able to handle that. But that's also a good take. Yeah. Any other?
Well, if you have a smart IoT doorbell with a camera, and if someone comes in, and that service would check the face on that. And,
Whether the person coming in actually belongs there?
Yeah, open the door for it. Or lock the door, for example.
I'd like to expand. Might be a problem of parking in the city where
Yep.
You have a space available for the cars, but market where you scan someone and recognize is this a person, your neighbor, or not?
Yeah, those are also good examples. Anybody else take the venture a guess or suggestion? You're being careful because you don't have any ideas, or you have a good idea and you want to use it in your hothouse session.
I have a question. There's also an idea that you could use, there's those suggestion boxes.
Yep.
Where you put written suggestions.
Yep.
So you could scan them and sort them by language, by so to direct them to departments within a company where those suggestions are meant to be, and like something like that.
I actually have to say that I like this one, but you already got a price. Sorry. That one is actually a really good one, because then finally the suggestion boxes would actually make a difference. Because yes, you correctly identified that there's a computer vision API that allows you to translate handwritten text to normal text. So you can solve the problem of doctors type of handwriting, or and actually like try to understand what's actually meant there, figure out the intent and department to whom this would apply, with a combination of kind of language analysis. So, all right, Olga, I will let you decide who gets the.
I have a question actually.
Sure, absolutely, yeah. I almost forgot about that. I'm sorry.
Let's say like I see Bing everywhere.
Yeah.
So let's say that someone is not happy with that and would like to replace it with any other search machine. Is that possible?
Well, you could use a search engine from Google, use their API for your search. The funny thing is that the efficiency of the search that's available in these cognitive services seems to be working better than the Bing search engine you would use for web. I don't know why or where the problem lies. Maybe I'm looking for the wrong stuff, but it's actually the responses that you get are more reasonable from this one, and I don't know why, so don't ask. Yeah. Yeah, but it's not something that you would go to Microsoft and say, well, can we use your Google's API in your cognitive services? For that, you have a Google service that does that, and you can get to use it the same way you would use similarly to use this one. So the pricing. I have to let you decide something as well, so I can't just point fingers and say, well. Yeah, I actually like that one as well, but I didn't want to. Make that decision myself. Yeah, so these real-world cases, like when we were talking about this session and what would be in this, and considering the concept of hothouses that you would be split up in teams, I see these cognitive services as a big part of the solution. You just have to, or at least I would, if I would participate in something like this, and unfortunately I don't have the luxury of doing so due to the time restrictions a bit in my life, I would go with these and try to figure out what can I make using these, or possibly connecting multiple of these together to create something new and interesting that could actually have a market potential. Yeah, so for vision, so image processing algorithms, you can actually identify and understand what's happening in the picture. So there's computer vision. You can figure out actionable items to do from the image. You can index videos. You can detect faces, understand their properties, their emotions that they're displaying. You can moderate content, either by analyzing images or text, and try to understand whether this is limited content or not. And the custom vision one is the one that I mentioned, where you can actually train your own recognition models for specific things. Yeah. So with emotions, I'll show actually a demo. Hopefully it will work with this one. Yeah, it not only detects the location of face, but also emotions in the range of 8 emotions that have been identified. You can analyze images and try to understand what's happening in there. There's also the age recognition and what's the content in it. And as you can see, the sample outputs, you can get the adult score, which is identification whether this is adult content or not. Recognition of the faces, different information about the picture you upload. Yeah, you don't actually get to hear the sound coming out of my PC, but you can use the speech ones to understand what's being said in the complicated situations where there's a background noise, different dialects. You can actually translate it to a meaningful, or not translate it, but write it down in a meaningful sense, so you understand what's actually going on there. Yeah, so speaker recognition, some of these you might be seen somewhere. You can identify, you can use one of the, another example that might be interesting, you could play around, because Microsoft has built a similar thing with their new new conferencing solution, where there's actually speaker recognition and automated meeting notes, where you understand who's speaking and what's saying, and you don't have to dedicate a person who writes notes in the meeting, because you can automate that part. You understand who's speaking about what and make notes of that. Eventually, you also understand who's being angry in the meeting and get the sentiment and understand what they're meaning by their, especially if they're not speaking in their native tongue, they might be, somewhat hard to understand. You have a custom speech service, and you have a Bing search where you can actually translate phrases to text and search on the result. Yeah. Yeah, so the translator speech, where you can actually, convert speech to text, then use the language-specific translation functionality, and then text-to-speech to reproduce the audio. Yeah, so you can actually simplify the communication between people of different nationalities who don't know each other's languages. This could be a helpful way to do it. Yeah, so this is one that I mentioned as well. Detect language, understand the sentiment, is it positive or negative? Quite a few applications in customer support, I would think, for analyzing the quality of the customer support. Mainly focusing on, well, making sure that the support professional doesn't get angry, or at least identifying when the cases that has happened, and work to improve this, and also understand the key phrases, what's being meant in there. Yeah, so you can do text analytics, spell check, understanding of the language. Yeah, translator text, also kind of self-explanatory. And language understanding models, which is another thing I mentioned, where you try to understand the actual intent and entities being discussed. Yeah, the bot thing with the knowledge base, I kind of mentioned this one as well. Yeah, you can create custom decision solutions, where depending on what you detect in text, speech, or video, you make a decision on whether to route. For example, your example with the police or emergency services might make sense if you can train the algorithm to detect there's fire burning in the background. So, could be doable. Yeah, Q&A maker, can also self-explanatory. Custom decision. Now it can personalize articles, customize content, optimize apps, and rank items. Yeah. Also pretty search. Also, really suggest to try out the search one. Search one might be.
We need 1 minute technical pause.
Sure. I think everybody's okay with that. I'm starting to see sleepy faces.
Yeah,
sure.
grab some mandarin, some water. Yeah.
We're almost done. I have a demo to show, which I would really like to show because I spent a lot of time on it. But so we'll solve the technical problems. We'll continue, right? Yeah. Any questions off the record then? No questions? There's still one prize to be won.
You just need to change battery.
I know, I understand. All right, then 1 minute break.
Jā, tūlīt baterijas izlādētas.
So just stick around and right. Nu, kā ir? Google pareizās atbildes?
Ko?
Google pareizās atbildes?
Nē, es tev uzdevu jautājumu tām instancēm, tāpēc pēc savas pieredzes viņiem ir 2 minimums.
Virtuālām mašīnām taisnība, jā.
Viņam taisa maintenance, backgroundā viņi restartē tās aplikācijas.
Tad es samaloju.
Tad,
You're saying I'm lying?
Jums?
Neizgulēšanās, es pusi aizmirstu.
Nē, ļoti labi, ļoti interesanti klausījos.
Ja neizstāstu uz cilvēkiem, skatīties, es neapmēr. Please.
You were mentioning us that the app can go from translation of to text.
Yep.
What will be the mode of which will capture the speech?
Well, you can capture the speech either just by sending a stream of data to your service that passes it on to the API, or you can extract it from a video you have uploaded. Yep. Yep.
Doctor has some kind of an initial the startup script.
Yep.
And then he will be interrupted with the service. He will ask the detail of the patient, and then he will go to the computer. He will ask.
So you would typically want to imagine a scenario where there's a doctor going through. Yeah.
So if something can just capture all this information.
Yeah. But that's the capturing part. You figure out whether you do it with a microphone and a PC, and whenever there's a connectivity, this gets uploaded and processed and parsed and inserted in a data store that would store that information. That would kind of list a list of complaints, age, and all the questions that you might ask, and depending on the scenario, because a scenario does play a role in the choice of what you make. Well, one thing is having a discussion with a phone. One set of requirements, second set of requirements is when you have a doctor's office where you have a recording, and whenever there might not be a network, and you might just take this and eventually upload it, because you don't really need that response or that insertion right away, unless of course you have a workflow where you actually rely on that information being available in your service straight away. For example, you might detect that a person is having a heart problem and you want to hand them over to your colleague specializing in cardiovascular ailments straight away. Yeah. And with these cognitive services, Microsoft, well, with this and other services, Microsoft is going to trend where they actually are containerizing this. You could actually use a container-based logic. You don't actually have to send the data away to the cloud to use a service like this. And the same applies also for machine learning models. You can train your own machine learning model, packages as a service, and run it in a container on-prem. Like a lot of IoT scenarios actually would benefit, like if you would have an IoT sensors in your building that measure the CO2 level, and in case there's a sharp jump in the CO2 level, you would automatically want to call a fire department. And you wouldn't want to rely on the traffic going first to Azure, then being processed, then being called. So running that service locally is also an option. I didn't discuss that, but that is would be one of the solutions you could utilize. Yeah. But that's again is depending on the service what you pass in. One service takes in a stream of speech, another one takes a video stream in. Different services, different things. Yeah. So, and depending on the use case, you apply. Well, you figure out how does the flow will go, because one is having a bunch of components that really work well independently, and the second one is figuring out the workflow, how the user story will go. And depending on that, how that story goes, you decide how to handle this. Yeah, because you could also even combine. You could use something like Lambda architecture, where you process certain set of events or certain set of information on-prem, and you store the rest of it then for later analysis at a later stage in a cloud storage. You don't really care when that later time comes when you do that uploading. It's a rather wide answer to your question, and I'm not sure that I answered your question at all. Okay. All right. Any other questions?
I don't have a question, but I think there may be a problem with private policy sometimes. Example, if I call 911 and or someone else, then they can't connect my camera or check
Yep.
my heart rate because I don't allow them.
Yeah, well, that's always the thing. That's why these services come with. And actually, when you check these services out, and the documentation says explicitly that the consent is required. If you do like facial recognition, I can't just without asking your consent take a photo of your faces and do analysis on it. The same applies for the other things as well. And obviously, if you want to rely on software that uses cloud services to possibly save your life, you kind of weigh out the risks versus what you lose by handling this information over. Microsoft has quite good, well covering clauses out how the data is then used. Each service has a different set of rules because obviously Microsoft then uses the data that we sent, some of it at least, that's can be anonymized, to improve the models that they use, the services as well, because you need a lot of data to train these models, and the more data you have, the better they work. So using customer data, well, obviously it has some problems with kind of consent-wise, but from a service owner perspective, I can see why. Yeah, and then again, you as the end user or the one who is handling your data over, you make the decision whether you're okay with that or not. If it's a life or death question, well, a different kind of approaches apply. But you wouldn't be happy to find out that you trusted your heart rate data and they keep sending you goddamn spam about dietary supplements, for example. But all right, that's a valid comment as well. Any other comments and questions, things that you want to discuss at this second? No, I'll move on then. Yeah, so search. We stopped the image search thingy. Yeah, you can find a specific item by picture. Yeah, you can figure out what that thing is and where you can get it. So you go out, you take a photo of an item, you don't know what it is, where to get it, and you can actually find, based on that metadata in that image, what you're looking for. Yeah, search. Well, it's exposed as a web search underneath, probably Azure search somewhere there sleeps. Yeah, so image search results by images, publishing information, all that, and you can give it the image and get back, or give it the search string and get back the images you require or look for. All right, that's all that I wanted to show you in the terms of presentation. I think you actually deserve the prize, so I'll hand it over to you because you actually asked the question last. And I said that the prize will be handed out by the end of my slides. Here you go, sir. Okay, so now I'm gonna do a bit of switchover, and I will need to take your photos. So think carefully if you give me your consent of doing that, and if you don't want to be in a picture that I show there on the screen as part of my demo, please avert your faces when I'm gonna do that. So I'm gonna switch over to the website front end, and we're gonna do that real quick. Yeah. Okay, so I've built instruction. Hopefully you're still live. So I've built a logic app that actually takes in a image from, takes an image from an email and analyzes the sentiment in the room. So we'll see how alive are you. I see you coming here. So anybody not okay with your data being sent over to Azure Cloud, avert your faces and leave the room, and/or, okay, so I will try to get some of you in. It will take a bit for this picture to be uploaded, and we'll see what happens. And then I will show a bit more on the code side of things. Give it a bit of time. It will take a bit to trigger. I will not switch off the screen, so you see I'm not cheating. As soon as the picture goes, we'll get it there. Hopefully, if the demo doesn't crap on me. It's happening again. Always happens with the demos. Because it takes it a bit of a time to do it. It seems that I will need to cheat a bit as well and check and upload a. So I promised to show you the bit of a my demo, which is not currently running because apparently my function app has gone down, is not running. So I have a deployment template, and I'm using a linked template pattern. Do you see any of the stuff that I show, or should I zoom in a bit more? No response? You can see well, or should I zoom in more? All right. As soon as I can find a way to do so.
Can you switch to white theme as well?
I don't know how.
Control+.
Well, that part, yes, but. So we're using a linked template approach where we, I will push this so I have where I have defined various parameters, and for every resource that we use, we have a deployment defined in resources and pointing out to a template. So we have one orchestrator template, this one, that does a deployment of various resources in the blob. Yeah. So I am in parallel trying to understand. This is not running as supposed to. Yeah, and this is the template definition. I'm sorry, I will have to I will disable this a bit. I will go into details after in a second. I need to check why my function is no longer available. But in worst case scenario, we are, oh no, we have that. It's actually worked. I don't know why the function didn't show up properly, but there we have it. This has detected 28 faces. I lost the moment where I switched. Oh, I had to switch over. Apparently, I looked at the wrong logic app. But these are the emotions that we got. 28 faces were detected, and the average, the top ranking emotion in the room is neutral. Typical Latvian reaction to everything. All right. So I will now show. So I have a pipeline that's going to deploy some updates to the page. Oh, it did actually finish. So most likely this is the reason why it started to work, because of the update that went through. You can, yeah. So, and if we take a look at, this is the logic app that we did, and this is, I apparently was looking at the wrong image. So basically, this is the flow. When it basically checks my email for photos or emails that have a subject of photos and gets the attachments, and for each creates a file in a blob, and then creates a SAS token that's a security signature to access the storage file, and then calls a function which I wrote to get the emotions in the room. And all of this is configured to be released using Azure pipelines. Yeah, so every time so that's a Azure DevOps tool, which you can also use for free, for a certain amount of time. So basically, all of what I've deployed and shown here cost me exactly nothing. All right. So we'll switch over to the presentation. Yeah, I will talk a bit more about the what happened there. So where did I put my clicker? Okay. So I have a logic app, yeah, that takes the email, stores it to blob, passes to the function, because the built-in connector for the cognitive services in the logic apps did not actually provide me with the information about the emotions. We can only get the face quadrants back. To solve that problem, I used the functions in the REST APIs to pass in the picture with a SAS token, because it's stored on blob, and typically you can't really access these files directly. So we needed that signature. I could have created that signature in the function code itself, but I didn't want to add unnecessary code to my function and just focus on what I exactly need to do, which is not covered by the connectors and components that are there. Yeah, then, well, the function makes a call to cognitive services, which provides us with a response that's passed to Redis. And then there's an app service that actually displays the front end. And it upon refresh, it checks the Redis record. The Redis is configured to keep the record for 5 minutes. After 5 minutes, your picture from this exposed web end will be gone. I use Devops Pipelines to do the deployments on those. So I have a fully automated, so I could delete the solution, deploy it again, enable the enterprise connector for the Gmail, and deploy it again. Using the same template in about 15 minutes, because the cognitive services, for whatever reason, takes quite a bit of time to actually create. But an update takes me exactly 3 minutes to deploy. Whenever I update the content of the function code or the web app or a code or the HTML code, is 3 minutes to update. So I can really quickly and agilely deploy this. The services, both the cognitive services and Redis use connection strings to them. None of these connection strings are actually stored as app settings anywhere, and they're not in the code. Every time the resource is created, I'm storing a secret value in the key vault. And in the app settings, I place only the name of the secret I need to read. Both the function and the app service uses managed identity, which is also automatically provisioned as part of the template. And I also have an access policy that adds that managed identity rights to get the secret value out of the key vault. In that sense, basically, none of my code base contains any connection strings, just names of the secrets I want to read. And managed identity gives the specific service permissions to read the secret value and use it in the startup time. So that's what's there. So with that, I thank you very much for your attention. You've been a wonderful crowd. You even asked some questions. Give yourselves a round of applause. All right, so that's it for my session. I'm going to stick around, so any of you have any?
We have a couple of questions from YouTube, our live stream.
Snap. So, I wasn't ready for that. All right.
So question number 1 from Pavel. Can in cloud run Oracle products, Oracle DB?
Yes, you can. There's a virtual machine offering from Azure, and there's even a great licensing offering for that as well. It gives a discounted price on the license because the cost of that license is also included in the virtual machine runtime. There's even a specific sizes of virtual machines that give a subset of cores, so you can actually actively save money on the licensing models, because you have a kind of you have a, with Oracle, if I understand correctly, and I'm not an Oracle expert, there's a core-based licensing model, and there's some specific Microsoft-created virtual machine sizes that help you kind of circumvent breaking the bank out of the gate on those. Yes, but there are virtual machine-based ones, as far as I know, and that changes from week to week. There is not yet a PaaS service for Oracle databases, but I may be wrong. Right?
Question number 2, tricky one. What about expenses? Azure, yes, AWS, yes, Google Cloud.
Again, it depends on what you use and where. And I'm sorry, I'm not an expert in the other two. But typically with virtual machines, they try to outcompete each other. There are no, when one gives discount to virtual machines, the other one tries to do the same. There are differences specifically on how storage stack operates. Some of them have quicker storage than Azure, I'm sorry to admit. At least some experiments and measurements have shown that. But pricing-wise, the virtual machines being the compare point, then I wouldn't say that one is extensively cheaper than the other. Strangely enough, even though Microsoft owns the license for Microsoft stack of applications and include that price of a license in there, you would kind of think that both Google and Amazon to run the virtual machines with Windows operating system, if you would do that, kind of would cost more because, you know, no discount on the license. It's not really the case as far as I know. So, and the rest of the services, you can't really compare them one-to-one. There are, of course, serverless offerings in both of them, but they're not really comparable one-to-one. So I think that the pricing argument then is not one that I would like to discuss on services that are not comparable one-to-one. That would be my tricky answer on this rather tricky question. That's a good one. Too bad we can't handle the price or handle the price virtually. A pat on the back then. Yeah. So there wouldn't be a conflict of interest.
I think no more questions.
That was sure.
I really enjoyed this. It was awesome, and because I'm new to Azure, I was just wondering if we can get our hands on the slides.
Sure. These aren't my slides. Most of them are done by Microsoft anyway, so why not? You can even, if you look real careful around the room, you can even find a card with some credits for Azure usage. I saw some somewhere. Oh, yes. And you can actually get like $200 to try this stuff out. And if you're really frugal and you really pay attention and don't spam up the most expensive and item with bling blings attached and everything premium, you can really make a run for those $200. That's a lot of money. I use a VSTS subscription. That's part of the company kind of benefit we get. And I have $50 a month. And if I'm really careful with that, I can't spend them all. Like I would be unreasonable in my choices of service levels to spend them. Obviously, production is a different story. But for trying out, like what I mentioned is, serverless components like logic apps, logic apps are priced per execution of a action. And you have a couple of million of those action executions for free for the logic apps. You have to remember that usually those rely on some additional services like storage. That's separately priced. You don't get the free storage on anything, but the storage is the cheapest commodity in cloud. With functions, you get, there's a strange measurement because functions are limited in RAM that you use. You get 400,000 seconds of RAM per month for free. That's a strange measurement, I know, but typically your function without too much code will take 128 megabytes of RAM. So you calculate yourself how many executions that is for free before you even start paying. So if you take all that into account, you focus on working with PaaS services, some of which are free. For example, the app service has free tier, which give you 60 compute minutes a month, meaning you don't pay anything, you share those resources. And every time a page loads, that's compute time. You're limited to 60 minutes a day. So for your development work, you're fine, but not for production. The cheapest kind of one that would be kind of okay for production is the shared one that's like 240 minutes. But both of these plans don't have a feature called always on, which means that after a longer period of downtime, when somebody opens your page, it will run quite slowly because it needs to load up. It's not in memory. So there's tips and tricks. There's quite a lot of ways you can save money and get the bang for the buck and not pay anything at all or pay a little bit. Like cognitive services, I mentioned, there's 1,000 calls to a cognitive service of your choosing per month with a rate limit of 10 calls per minute. If I remember correctly, you have to check for free. And then you pay for millions of calls, something in the vicinity of dollars something. All of the pricings, you know, they change. I can't keep track of them. I can only talk about the models of pricing. So the price questions, I'm really surprised that none of you asked about the pricing models in play, but typically that's depending on the tier and the number of minutes you run on that tier. So it's per minute based pricing. So you need something to run quickly, you spin it up to a different tier, that's higher one, you run it for that certain time, you scale it down back again to free if you need to. And you can, if you're really careful with that and you automate these operations, you can get this running quite cheap. But obviously, if you just click, finish, and then you don't read, and with Microsoft services, word of advice, check what is the default tier they're setting up. Like Cosmos DB, there are no SQL database service. By default is configured when you just do next, finish, you get 10,000 RUs per hour, or what was the measurement? RUs per second, I'm sorry. And those unfortunately cost you something like $40 per day. And that's an exceedingly big amount of capacity you don't actually need. So you kind of have to like check what's the tier that's by default enabled and make a conscious act of choosing more kind of price performant one based on your requirements. All right, that's all the additional nuggets I wanted to share publicly then. I have to stop before I destroy this thing totally. Thank you.